Okay, we have two more problems to do, and we are done with uh, time domain solutions, the time domain methods of solving differential equations. Then we move to start the process of moving to Laplace. All right, so here's our next example. So our next kind of input we're going to handle is where f of t is a sinusoid. Okay, so here we have our second order system equals 9f of t. So everything's the same. We're just changing the input to be a sinusoid. All right. Once again, we're going to use e to the minus 3t cos 3t plus phi as our complementary. So now we need our particular. All right. So we've done this before. So it's going to be the same thing. Our particular solution looks like c1 sine of 4t plus c2 cos 4t. So we're going to take this, substitute it in here, solve for c1 and c2. Okay, now I will note we could do this as a sine or cosine 4t plus a phase. That would work as well. But this is not too bad to work with. We'll just stay with this. All right, so we take, these are sines and cosines, so they have second derivatives. So if we look here, we have the second derivative of this term. All right, so this becomes minus 16c1 sine of 4t and minus 16c2 cosine of 4t. Then we have to take 6 times yp dot. So if you look at what this is going to, so we have the 6 here, that gives us the 21c1 cos 4t and 24c2 sine of 24t off of that one. And that doesn't show up so good, so we'll darken it up a bit. There we go. All right, then we have 18 times this directly, so we can just stick that in, equals our 9 sine of 4t. All right, so we've done that, so now we're going to gather all the sine terms and the cosine terms as we've done before. So here's all the sines, plucking all these down here. And the cosines, well, there's no cosine over here, so that's a 0. And so now we can solve this. So here I gather the terms, winds up with this set of equations. I'll leave that for you to check. All right. And here you solve for C1 and C2. It's just a matrix inversion. You get C1 is 9 over 290 and C2 is minus 108 over 290. Okay, so now we have our particular. This is the steady state solution of this thing. All right, and once again, we can reduce this. We can write this as one sinusoid. Okay, so namely I'm going to write it as a cos 4t plus phi. All right, so if I do that, this is what the cosine looks like, a cos 4t cosine phi minus a sine 4t sine phi. Okay, all right, so a lot of work. So now we have to, so let's see, we have the cos 4t, so a cos phi is 108 over 290. Take these terms, they go together. Here's the sine 4t, so a sine of phi corresponds to this. Minus, minus, so we just have a sine phi is that. Okay? And we've done a bunch of these now, so I will leave this for you to check out. But if you square this and square that, take the square root, that'll be the a squared. Okay, there's that. And if you have a sine phi over a cosine phi, do an inverse tangent, you'll wind up with 4.76 pi over 180. So we've done a bunch of these now. I'm going to leave this. You check this out. You need to be able to do this. This is the kind of nastiness that I can put on an exam. All right. So now we have, here's the particular, right in here. And now we need our complementary. Now here's what's interesting. We have a sinusoidal input at 4 radians per second. Notice, now I'm expressing this as a cosine. By a phase shift, we could express this as a sine. But we get a sinusoid. We have an input at 4t, we get an output of 4 radians per second. But Here's the complementary. It's going to actually oscillate at 3 radians per second. So there's going to be 2 sinusoids working in here. This one is the steady state. Nominally goes on forever. As long as this input keeps going, that's what this one will be. However, to take us from our initial conditions to this, we have this oscillation happening. E to the 3it, so it's dampening out, but it's at 3 radians per second, where 3 is the damp natural frequency. Okay? So we've got this. Now we simply have to do our usual y of t of 0 equals 2, and then y dot of 0 equals 4. So we take this, we let time equal to 0, equal 2. Okay, so if you look at this, when you let time equal to 0, you're going to get cos of 4.76 pi over 180 times 108, works out to 108 over 290. Okay, the minus sign comes down. Set everything equal to 0, you get a times 1, and then cos phi. So we can solve for cos phi. All right, a little bit more work here. So we have to take the derivative, set it equal to 4. All right. So we take our derivatives. We already know a cos phi, so we can insert that in here. Okay. And we'll solve for a sine phi. And that works out to, so here's a cos phi. When if we work out the numbers, works out to 2.37. A sine phi is minus 3.362. Square these, take the square atoms, take the square root. Here's A is 4.36, and our phase is minus 57 degrees. Okay, and so I've stuck them in here. Here's our A, and here's our phase. And this problem has been knocked out. We have one more to do, and that's with an impulsive input. We'll do that next.